Hello, welcome to the SPAG Bootcamp video series. In this video, we're going to talk about configuring two-way delay measurement using Y1731. The two-way delay measurement Y1731 uses the CFM to establish the endpoints to measure delay and then loss. So in order to do that, first we're going to configure CFM between R1 and R3. In the previous lab, you would have configured CFM between R1 and R3 for the Ethernet OEM purposes. So here we're going to do the same thing, but here we're going to change the monitoring endpoints a bit, and then we're going to have the MEPs configured on the interfaces of R1 and R3, which connects to the edge devices ASR9031 and ASR9001. So if you're looking at the topologies, the MEPs will be the GIG02 interfaces on R1 and R3, which connect to the 903 and 9000. So first, what we're going to do is we're going to configure the CFM. So to configure the CFM, first we configure CFM IEEE and then global. These are the global commands: Ethernet CFM, IEEE, and global. Then we'll define the Ethernet CFM domain. The Ethernet CFM domain name is 2DM. Again, I'm using level 5 based CFM, and I'm configuring the service name as SCR1 with EVC pod 1, which is already defined. And it's VLAN 100. So do keep in mind that the direction is down. This is because I'm configuring the Ethernet CFM on the interface right here, GIG02 interface, which connects to ASR 9001. So the direction down, in the sense the CFM has to go down the wire to towards the 9000. So that's the reason the direction is mentioned as down. And once I've done that, I go to the interface. So let me jump to the interface. This is the interface which connects to the ASR 9001, and as usual, I had to take the service instance off and put the service instance back in with the defined EVC pod 1, encapsulation .1Q200 and second .1Q100. So, and then the bridge domain, these configurations stay the same. And I define the CFM configuration, which has the MEP ID of 15. And let's look at the other end, that is the R1. On R1, the Ethernet CFM configurations are identical to what we have on R3. And on the interface, GIG02, we have identical configuration, except the MEP ID is different because the endpoints have to have a unique MEP ID. Now, when doing delay measurement, the delay measurement Y1731 uses IPSLA CLI. The IPSLA CLI is configured on the platform where you want to actually measure the delay from, the back and forth delay from. So I've configured IPSLA 11. This is the ID of the delay measurement configuration. So the configuration is, I say, under the IPSLA 11, I say Ethernet Y1731 delay DMM, which means that I'm measuring two-way delay. I mention the domain. I associate with the CFM domain, which is 2DM, and the EVC, that is part of the domain, and then I'm measuring the delay on which is pod 1. And then I mention the MPID, which is the remote MPID of R1, and the MPID is 14 here. So if you see here, both are common. And I set the cost value, which is 0, and the source MPID is the one local to the box, so 15. So if you look at show interface GIG02, the MPID that I mentioned there was 15. So this is the source MPID. So we talked about now this this configuration talks about the delay measurement IPSLA configuration. Now I'm going to jump to the IPSLA configuration for the loss. For the loss, again, I define another IPSLA ID, which is 12, and I say Ethernet Y1731 loss, and by mentioning loss, it says that I'm measuring the loss measurement. And once the loss option is mentioned, you mention what type of loss measurement you're using. This is synthetic loss measurement, SLM. And again, the same CFM attributes are associated with the IP-SLA configuration. Domain 2DM, EVC pod 1, remote map ID, which is 14, and then the local map ID is 15. So these are the configurations that you would need in order to configure delay and loss measurement in IP-SLA. Now once the IP-SLA has been configured, what you would do is you would go and then you would start the IP-SLA measurements. So to do that, what you would do is you would require these two commands. You would say IP-SLA schedule, and then you would use the SLA ID, which is 11, and you would say start time now. So it immediately starts off once you give the configuration. You do the same thing for the loss as well. So once that is done, I'm going to see the loss and delay using the command show IP-SLA statistics 11 and then detail. So here you would see that the IP-SLA configurations are running, and the two-way delay measurements would be shown up here. And to measure the loss, for the loss we used IP-SLA configuration of 12. So here is the loss measurements, and in order to do that, it's always, in order to actually see the output in a detailed way, it's always better to use detail. The output may not have the statistics now because it's been a while I started it. If I started now, you can see the observations and then statistics running. I hope you enjoyed the video of configuring Y1731 delay and loss measurement, and I hope you have fun configuring in the lab as well. Thank you.